to solve that last question, we would need to know more information. Okay? We would need to know the relationship between mass and the amount of wheels, okay? Or the mass and the amount of frames. We have to have that conversion factor. Once we have that conversion factor, then the equation is useful and I can go through and use that. Okay? So we have to be able to go from mass to a counting unit. In chemistry, what is our counting unit? It's a harder question. Depending on how you spell and if you pluralize 3 or 4. 3 or 4 letters. Mole, if you decide to not pluralize it. Okay? And if you just spell it like the way I do, MOL. Okay? Or moles. That's our counting unit. Okay? We use that as our counting unit because we're trying to scale things up to measurable amounts so that I can use units of grams and pounds. Okay? Without having to deal with massive, or sorry, really, really, really tiny powers of 10. Okay? So, looking at our equation, if we scale this now to chemistry, we have a chemical equation, and that chemical equation now allows us to relate different things. So if I'm given 2 molecules of nitrogen oxide, I know it needs 1 molecule of oxygen to react with it. Okay? And because I have the balanced equation, I also know that I need 2 molecules of NO2 would be produced. Okay? That's actually an equality. In fact, that's multiple equalities. Okay? What I'm saying is 2, I prefer the abbreviation MLC for molecule, molecules of NO equals 1 molecule of O2. Okay? I also know that 2 molecules of NO equals 2 molecules, where'd it go? NO2. Okay? And because we started down this path, we might as well finish it out. I also know that 1 molecule of O2 equals 2 molecules of NO2. Good. Why'd you not say NO? I already have that one. That's the very first line. So the chemical equation gives us those equalities. Okay? Depending on what we're trying to do, we may need to use one of those equalities. Okay? We will only use one at any given instant. We won't use multiple. Okay? Because if I use multiple, I'm now relating 3 different substances, and the problem with 3 different substances is too many variables for me to control. Okay? So how could I go through and use one of those? Let's pick the top one. How could I convert that top equality into something useful? Not moles, not even grams. Because right now as an equality that isn't useful. Because as an equality that doesn't fit in our standard conversion process, right? We need a unit factor. How can I convert that top expression into a unit factor? Okay. I could divide both sides by molecules of O2. This gives me the unit factor, 2 molecules of NO over 1 molecule of O2. What would that equal? It does not equal 1 molecule of O2. It does not equal 2. Say that again?
1.
It equals 1. Right? Equals? Equals, right? What is 1 molecule of O2 divided by 1 molecule of O2? 1. What does that factor equal? 1. That is actually why we can use it as a conversion factor. So that if I started with a question, right, where I was given, say, 52 molecules of O2, and I wanted to know how many molecules of NO could have been produced. Okay. Well, our basic equation would be, well, molecules of O2 needs to be in the denominator because I need the unit to cancel because it doesn't show up in my answer. What do I want in the numerator? Molecules of NO. Okay. What numbers should be associated with those? 1, O2 is, did I do that right? Yeah. 2 molecules of NO. There's that expression. There it is. It just appeared. Okay. Why am I allowed to multiply that expression in there? What does that expression equal? 1. What is any number times 1? The same number. Okay? So I'm allowed to put that expression in there because it doesn't change the meaning. Okay? What does it change? It changes the unit. Right? So that allows me to take one meaning and change the meaning, or keep the meaning, but change the unit through that expression. That's the whole point of it. The chemical equation gives me those coefficients. The mathematics behind it is this equality, and all we're doing is saying, well, which equality do I want to use? Which number 1 do I want to multiply by? Because I could have just as easily said I want to multiply by 50 over 50. That is perfectly fair. Does that convert the unit? No. Numerically, it's doing the exact same thing, but it doesn't change the unit. The whole intent is to manipulate that unit without losing the meaning of our initial intent. Kind of make sense? Okay? So we're pulling coefficients off, and we're bringing in a counting unit of just molecules. Right? Really, the 2 is the counting. I'm counting 2 things. What are those things? Molecules. Do I have to count 2 molecules? No. What else could I have counted? Not yet. We could have counted 2,000 molecules. Okay. How many molecules would that be for O2? Okay, 1,000. How did you do that? Okay. You're recognizing the pattern between these. 2 to 2,000 is 1,000 times. So what should the O2 be? Okay. The same thing. I'm multiplying by 1,000. I'm making that comparison. So it would be 1,000 molecules. I don't have to write it because I can disappear it. How many molecules would that be of NO2? 2,000, because I'm doing that multiplying by 1,000. Okay? So that's the power of our chemical equation. The issue with even 2,000 molecules is that that isn't big enough to measure. Okay? So what do I decide to scale it up to? Okay? I decide to scale it up to 6.022 times 10 to the 23rd molecules. Okay? And that seems like a random weird number, okay? But all I'm doing is scaling it up. What does that mean the NO should be? So one option we could say, well, how does 1,000 become 6.022 times 10 to the 23rd? Can anybody see that one easily? I'm going to guess by no hands, that's going to be a no. I would agree. I think that one's difficult to see. So let's erase that line. How do I scale from one molecule to 6.022 times 10 to the 23rd molecules? I multiplied by 6.02 times 10 to the 23rd. So what should I do for NO? 2 by 6.02 times 10 to the 23rd. And what happens? I get 12.04 times 10 to the 23rd. What should I do for the NO2? Same thing. The scale factor I'm using is now just 6.02 times 10 to the 23rd. The result being end up out there. Okay. Is anybody happy with those numbers?
No.
Why not?
Should be 1.204 times 10 to the 24th.
Touche. 1.204 times 10 to the 24th. Okay. So he's making the argument this is not proper scientific notation. Fair enough. I'll accept that. Does anybody else have a complaint about these numbers?
They're still really big.
Those are really big. How many of you are comfortable with powers of 10? Okay, 2 people. It would be really nice if I could invent a system that gets rid of the power of 10. Okay? To get that calculation, this was 2 times 6.02 times 10 to the 23rd, right? And I'm not going to worry about the units. This was 1 times 6.02 times 10 to the 23rd, right? What do all these numbers have in common? 6.02 times 10 to the 23rd. So what am I going to do? I'm not going to cancel them all out. I'm going to invent a unit. Okay. That unit I'm going to define as, sure, yeah, the name of my new unit is moles. What am I going to define a mole as? 6.022 times 10 to the 23rd. So that instead of having to deal with 12.04 times 10 to the 23rd, I'm starting to get sick of saying 10 to the, okay? I can write this now as 2 moles. Okay? For the second one, or the middle one, I could write 1 mole. The next one, 2 moles. What is interesting about those numbers that have now been put in there? Where did that 2 show up? Yeah, there, and the coefficient from the balanced equation. Okay? Because all I've done is scaled everything up by the exact same amount. The coefficient from the balanced equation still swaps in. This allows me to now be in units of moles as my counting. Why is it useful to now be in moles? If I measure out 2 moles of NO, I can weigh it. What would 2 moles of NO weigh? Okay, so let's clear up some space there. 2 moles of NO weigh. What am I solving for? Weigh. Weigh is mass. I probably want to do grams. Why do I want to do grams? That's our core unit for mass, so it's probably the easiest one to deal with. And because the instructor didn't give me anything better than that, I'm going to stick with that until told that I have to switch to some other mass unit. Okay? And what did I say I was given? 2 moles of NO. Are those 2 substances the same? No, so what do I do? Sorry, the substances. Are the substances the same? NO, NO. Nitrogen oxide versus nitrogen oxide. Is the substance the same? Yes. Is the measurement the same? Moles versus grams. So what do I have to do? I have to do a conversion. In that conversion, I want to cancel what? Moles of NO. What do I want to appear? Does that conversion factor exist? Yes. Where's that conversion factor found? On the periodic table. So we could look up nitrogen and oxygen, and we would get
2. You need 2 NOs, right?
how many NOs do I need?
And that one you're going to need 1.
What am I converting? Grams of NO, moles of NO. Where's the 2? Out there. Does that 2 have to do with this conversion factor? No, so don't use it. It's not there. Okay? How many nitrogens? 1. What's the mass for nitrogen? 14. Whatever. Oxygen? 16. So we could add those two numbers up and we would get 30, yeah. 30.01 for you sig fig freaks.
0.02. Well, no,
01. It's 01. Okay. What is that 30.01 tied to? Okay. That number was the number underneath our element, right? That number is known as what? I don't accept AMU. You're giving me a mass unit, and that's okay, which I kind of just gave away the answer. What is the number underneath? Molar mass is still getting is appropriate, is atomic weight. The periodic table tells you it's an atomic weight. What is the measurement for weight? Grams. The 30 should go with which unit? The grams, because it is an atomic weight. That numerical value is tied to the weight. Which unit is a weight? Grams, which means 30.01 grams. What number goes with moles? 1. Okay? Now I can do the math, and I would get 60.02 grams of nitrogen oxide. Okay? An initial shout out was made, well, it's 60.0 grams of nitrogen oxide in our conversion. Okay? What you did was combine the given information with the conversion to get the answer, instead of just doing the conversion. So you've condensed the work. You're starting to do an algorithm. The problem with doing that algorithm is if I plugged in 60 there, what happens? I'm going to get double the answer. So you have to be very careful that when we go through and process our conversions, we aren't doing extra manipulations. We are only doing the exact manipulations given. Okay? In this case, it is nitrogen oxide. Just because that says moles of nitrogen oxide, that is not the given information. This moles of nitrogen oxide is tied to grams of nitrogen oxide. Okay? The number associated in the denominator here is not the same as the number there. In the denominator, that's part of a relationship. The given information was just given information. Okay? And the reason you want to do that calculation in your head is because it's easy. So you go, oh, if it's easy, I can just do it. Don't. Your brain is going to mess with you all the way through. Write the work down, only answer the given information. Once you've established, and one of the things you can do with this, is once you've established what your conversion factor is, okay, what units you want, to find that number, what should you do? Oops, not that eraser. Let's try that eraser. I know that is my conversion factor. I want the relationship between grams and moles. Okay. What information on this slide should I be looking at? What information on this slide should I be looking at to find that relationship? Periodic table does not answer my question. What information on this slide should I be looking at to figure that out? What information on this slide should I be looking at? Nothing else. That's it. That's the only thing I can look at. The question may say 2 moles of nitrogen. I don't care. This is the only information I have. As soon as you establish a conversion factor, that is it. That is the only thing you have access to. There is nothing else in the world. Now the question becomes, where do I find that information? And you can go to the question, and in the question, what should you be looking for? You should be looking for an expression that relates moles to grams, which means an equality. Is 2 moles of NO an equality? No. How do you know 2 moles of NO is not an equality? For it to be an equality, what do you need? You need an equals. There isn't one, which means ignore it. Where do I find grams to moles? Periodic table. What am I looking for on the periodic table? The molar mass for what? Nitrogen and oxide. How many nitrogens? How do I know it's only one? That's why I write the substance here. There's only one associated with that nitrogen. Okay? So we run into this pattern of seeing units and being like, oh, well, there's a number associated with that unit, so I'm going to throw it in there. Stop. That unit there is combined. These are inseparable units. They must be tied to each other. Kind of, sort of? Okay. So, we can get a bunch of mole relationships. There's a whole slew of them, and here we could all see them come out of that. All of these are coming from those three equalities. Depending on which way you put it, you get a different equality. Kind of make sense? Okay. So depending on what we want to do, this single equation gives me 6 questions. One equation, 6 questions. So some people want to memorize formulas. Okay? By all means, you can go ahead and swing away with formulas or memorize how to solve one question. This one equation gets me 6 different questions. Okay? Instantly. So if you want to memorize a single process, that becomes problematic because now what do you have to do? 6 different processes for a single equation. How many different equations are there? An infinite amount. So an infinite amount times a minimum of 6 different conversions is going to be a lot of stuff to memorize. So what you need to be thinking about is how to pull the information out of the information that's given, not just memorizing a process. Memorizing processes work great when it's a redundant process and that's all you have to do. Okay? That would be something that you could do when you get a job. Because in the job, you're probably not going to be expected to work with a whole bunch of different systems. You're expected to work with one system. Right? As a nurse, you aren't expected to do surgery. Right? Yeah. We might teach you about surgery. Why? Are there nurses in the operating room? Do they need to know roughly what the doctor's doing? So they could be like, you drunk idiot, stop it. That's not right. Get out of here and get some other person in. You're a check for that. But what if you're not, well, there's bad cases. Right? Are there other nurses that never make it into the operating room? Do they need to know about surgery? Probably not. Do they still have to learn it in school? Yeah? Why? They might end up being there. Okay, so what we're trying to do is give you that entire background so that you have an idea on where you could possibly go. So that when you get there, you can now focus in training on just that one topic, but you know where to find the information. That's what your education is about. Not trying to train you for a job, but trying to train you for all jobs. So you might say, well, that seems really daunting. It is. Welcome to education. Okay? That's called being an adult, which some of us never make it to. That's okay. Yes?
Yeah, the bottom right one.
I don't know. I copied it from the textbook.
It's supposed to be 2 moles of NO over 1 mole of O2.
Yeah, that one is wrong.
I was like, how did you get that?
Yeah. Ah! So as was called out, that lower right-hand corner, did I erase the right one?
Yeah.
2 moles of NO over 1 mole of O2. Okay? Kind of, sort of? It's kind of warm in here, isn't it?
Yeah.
Okay, just checking. Because it feels really hot in here. So how many moles of oxygen react with 2.25 moles of nitrogen? Set it up. The beginning is? No.
Oh, right.
What do we want? We want Moles of oxygen. Anybody want to complain? Should it be O2? Yeah, why? Oxygen is diatomic. If I wanted that to just be a single oxygen, what would I have to change? I would have to say oxygen atom. Does it say oxygen atom? No, which means Mike is a horrible person and wrote the wrong answer. O2. Okay, what did you start with? Ooh, good. Moles of N2. So Mike screwed up again. N2. How many moles of N2 did we start with? 2.25. You have to be careful and make sure that you read the question associated with it. Okay, 2.25. Is moles of O2 the same as moles of oxygen? No, so what do we need to do? Do a conversion. So we'll set this up. What do we want to happen? Moles of N2 needs to disappear. What else needs to happen? Moles of O2 needs to appear. Okay. We now have a conversion factor. I would have to find that relationship. Okay. So I need to see an equality. Where is the equality found? So a periodic table gives you information about individual elements or individual compounds if we added up their masses. Is N2 the same thing as O2? No, those are different substances, which means, does the periodic table tell you information about this conversion factor? No. Periodic table only tells you about a single substance. That's why we have the boxes around each of those individual elements. Those substances are different. The periodic table can't help you. Okay? So where do I find the conversion factor for substances? Right? How many bikes can I make with 2 wheels? 1. How'd you do that?
Converted it.
How did you convert it? Why do you know 2 wheels belong on a bike? That's how bikes are made. Where do we get the information about how they're made? From a formula, a recipe on how to build it. That recipe is the chemical equation. So if I'm looking at converting substances, what do I need to move to? The coefficients from the not quite formula. Product. Okay, so I'll use 2. 2 what? Nitrogen oxide. Is that nitrogen oxide? No. Is that nitrogen oxide? No. So using the formula didn't help me. What am I using?
The units.
The units, moles. Where does it say moles? Okay. There's a better word for it. I want to use the chemical reaction that shows the relationship between those substances. What from the chemical reaction do I need to use? The coefficients. When are those coefficients valid? So for instance, can I use the coefficients? Why not? The equation's not balanced. When can I use the coefficients? When it's a balanced chemical reaction. It must be balanced. How do you know it's balanced? You've balanced it. You've checked it. Okay? The one other option is a kind of cop-out. Sometimes maybe you can get away with, though it could be risky. How else would you know it's balanced? You were told it's balanced. That can be dangerous because we could have easily have made a mistake and it ended up not being balanced. Okay? But if you're told it's balanced, you can kind of run with that assumption, particularly if you're short on time. Okay? Is this one balanced? Yes. Now, yes. Okay, so now I can use the coefficients. Well, I got a 2, so let's put the 2 in. Why do I not care about the 2?
That's not what.
That 2 is tied to what substance? Nitrogen oxide. Do I care about nitrogen oxide? No. What do I care about? Oxygen and nitrogen. What are the coefficients tied to those? 1 and 1. What happens to the units? The moles of nitrogen cancels. What unit would I now have?
Oxygen.
Moles of oxygen. Do I need to use the periodic table?
No.
No. The number on the periodic table gives you what?
Grace.
Weight is a nice broader term. Mass is more appropriate. We could use grams or we could use AMUs. Grams should be your primary focus because we can measure with those. And officially it's not giving you grams, it's giving you grams per mole. It's a conversion. Okay? Do I care about mass at all? Nope. So don't use the periodic table. Okay? Kind of, sort of? Okay. I want to address a couple things that I'm still seeing as I walk around. I'm seeing people write out the question. You already have the question. It's in the slides. Look at the slides. Those of you looking at the slides, you're like, I don't have to write anything because the answer's already there. Because yes, the answer is already there. Okay? Selective vision. Don't look at the answer. Still write it out. Okay? Why? Practice. The next part, almost everyone will look at it and go, oh, well, I get it now. I see the answer. It makes perfect sense. It's the effing answer. Of course it makes sense. Okay? If it doesn't make sense, then that's problematic. Okay? On multiple tiers, because you don't understand why things are going in. If you look at it and you're like, oh, that makes sense because the units cancel, and there it is. That's because it's the answer. How did those things get put into it? That process of why did I put things in those particular circumstances is really, really important. Okay? That process only gets revealed when we solve a question. Okay? If you're just looking at the answers, all you're doing is memorizing a single solve. That single solve is highly rare to get asked again, which means you've done yourself a disservice and you won't be able to answer the questions correctly on the exam. Make sense? Okay. So, how many moles of CO2 are necessary to make 1 mole of sodium hydrogen carbonate? Is that worth doing? A long enough pause, I guess, means yes. Okay, so we'll go ahead and write it out. What are we solving for? Okay, I'm solving for 1 mole of sodium hydrogen carbonate. All right, I write my goal. There it is. There's my goal. What's the fun thing about my goal? The whole point is to figure out what the number is associated with that unit, right? What did I just write in front of it? 1. What have I done? This is one of those like really obvious things that you're like, you can't really be saying that. If that's my goal, what have I done? I've completed it. I'm done. That was suspiciously really easy. Maybe I made a mistake. What am I solving for? Moles of CO2. Whoops. Do I know the number associated with the moles of CO2? No, that's why I'm solving for it. Okay. What am I given to start with? I'm not going to accept 1 mole of sodium hydrogen carbonate. Try again. Moles of sodium hydrogen carbonate. What is the number associated with that given information? 1. Okay. Are moles of sodium hydrogen carbonate the same as moles of CO2?
No.
So what do I need to do? Convert. Where moles of sodium hydrogen carbonate go on the bottom and moles of CO2 go on top. Okay. Notice what's happening. What am I changing? Is the measurement unit changing? No, what's changing? The substance. Where does the substance change occur? In a reaction is half right. Nice addition of a word, but still not only half right. Those of you at home, in a chemical reaction is still not fully right. No. Chemical reaction is pretty good, but it's not quite perfect. What's the extra thing that to make it perfect? A balanced chemical reaction. It must be balanced. Okay? You should fully expect that on the exam you will have to balance an equation to then be able to go through and do the solve. Okay? That is part of your knowledge bank. You have to be able to do that. Do you have to balance this one?
No.
It didn't say it was balanced, so arguably, yes, you should go through and balance it, but what some people have already discovered is it was balanced. You're welcome. Okay? Numbers associated with CO2. 1. Number associated with moles of sodium hydrogen carbonate. 2. What's the answer? Half a mole of CO2. Can I have half a mole? I mean, because if we had those as molecules, so that doesn't work, right? Why does it not work if it were molecules?
Because you can split them. We have to have.
I can't split a molecule. So why is it okay with half a mole?
Because it's multiple molecules.
A mole is a massive number of molecules. Can I have half of a massive number?
Yes.
Yes, that is perfectly valid. Right? This is one of the things that makes the mole useful. I can now have fractional values for moles. I couldn't have fractional values for molecules. Look at the practice exam. Okay? Just so you're aware. We good? Let's make it a little more challenging, maybe. Let's see. Sodium hydrogen carbonate are produced when 1 mole of sodium carbonate, 1 mole of water, and 1 mole of carbon dioxide mix. Didn't we just like do that? Not quite, because now what are we solving for? Moles of sodium hydrogen carbonate. What am I given? 1 mole of sodium carbonate, 1 mole of water, 1 mole of carbon dioxide. Okay, that 1 mole ends up being distributive here. Does that change anything? Okay. So one option is saying that's the equation just in words. So what you've started to do is solve the question out in your head.
The equation.
Sort of.
The answer would be 2 moles.
Sodium carbonate, what's our conversion factor? Moles of sodium carbonate. That says carbonate. Moles of sodium hydrogen carbonate. It is only getting warmer in here. You all need to stop breathing. Okay, sorry. We all have to make sacrifices. We'd get 2 moles of sodium hydrogen carbonate. In that calculation, did I take into consideration how much water was present? No, so what do I have to do? I have to do it again, but now consider water. Did I take carbon dioxide into consideration? No, so what do I have to do? Do it again. Take carbon dioxide into consideration. For those of you that were able to propagate through, you might have said, well, 1 mole of sodium hydrogen carbonate, or sodium carbonate, is the coefficient from the balanced equation. And I'm going to end up getting, as moles for sodium hydrogen carbonate, 2 in all cases. So shouldn't I get 6 moles? Right? Each of those solve out as 2. Shouldn't it be 2 plus 2 plus 2? That gets me 6. Why not?
Each one of those is required for.
Each one of those caps at 2. Okay? This would be 2 bicycle frames, or 2 wheels and 1 frame. It makes how many bikes? 1 bike. So 2 wheels makes 1 bike. 1 frame makes 1 bike. So I get 2 bikes. No, the pieces went in to make the 1 bike, you fool. You can't do that. Same thing's happening here. We can see that with bicycles. We can't see it as cleanly with chemical reactions because we don't have that tactile response, that visual knowledge. Kind of makes sense? So let's make it more difficult. What is the mass in grams of sodium hydrogen carbonate produced when 2 moles of CO2 are consumed? I actually didn't make this one as hard as I thought I was going to do, so I guess that's nice. What are we solving for? I don't accept grams. grams of sodium hydrogen carbonate. Just for the record, because I've been doing it, saying NaHCO3. I've heard lots of chemists like freak out at that. You should be saying the name of the compound and not saying what the letters are, just so you know. I clearly don't care because I do the same thing, but just be aware of that. Okay? What were you given to start with?
2 moles of CO2.
I do not accept 2 moles.
Moles of CO2.
Moles of CO2. What is the number associated with those moles of CO2? 2. Okay. So now we've got our starting information and we can compare across the equation. What happened to our measurement unit? It changed. We went from moles to grams. So we're going to have to do a measurement conversion. What else changed?
The substance.
The substance changed. CO2 to sodium hydrogen carbonate. So we're going to have at least 2 separate conversions. One is running the the measurement unit, and one is doing the substance unit. Make sense? Which one do you want to look at? Okay, substance unit. Okay, why might you pick the substance unit first?
So that you're already have the sodium hydrogen carbonate, from there you go to grams.
So you've got the substance finalized. I would argue that's reasonable. What unit is associated with a substance conversion? So when we convert through our chemical equation, what unit are we in? Moles. If I convert this moles into the mass unit, grams, can I use the chemical equation anymore? No. So generally it makes sense to get your substance converted as quickly as you can. Okay? The only way to do that conversion is through the mole measurement unit. Since I'm in the mole measurement unit, I might as well do the substance conversion right away. Okay? Because that mole measurement is the only one that allows me to use the chemical equation. Kind of, sort of? Okay. So, what unit needs to show up on the bottom? Half right. Moles of CO2. What unit needs to show up on top? Moles of sodium hydrogen carbonate. Where's that conversion factor found? That is not found in the periodic table because the periodic table gives you weight or mass. There is no mass measurement in moles. Where do I find the conversion factor between moles of one substance and the moles of another substance? From the balanced chemical reaction. So I can go back up to my chemical reaction, which was conveniently balanced for us, and we can pull our coefficients off. What are our coefficients? 2 for sodium hydrogen carbonate and 1 for CO2. What happened to my unit? Okay. I now have a new conversion because I have moles of sodium hydrogen carbonate that needs to become half right, grams of sodium hydrogen carbonate. Okay. Are those two the same? No. What's different about them? I don't quite accept the unit because the unit has 2 pieces, a substance and a measurement. What's different about those? The measurement. Okay. The substance is always tied to it, so I can't do them independent of each other. Okay, so moles of sodium hydrogen carbonate and what goes in the numerator? Grams of sodium hydrogen carbonate. Because the substance is the same, what could I now use? Now I can use the periodic table. Okay, and the periodic table gives me our grams over moles. Sodium is 23, close enough, plus hydrogen 1, plus carbon 12. 16 times 3 is 48. Anybody better at math than me? At least half the class should probably say yes. 84? 84 what? Grams. Okay. The number is tied to the mass unit, so grams per mole. Our 84 goes up in the numerator, moles denominator. Okay. What happens to your units? The moles of sodium hydrogen carbonate cancel. What would we be left with? Grams of sodium hydrogen carbonate. Is that what we want for an answer? Yep. So now we can do the math. 2 times 2 is 4 times 84. 336. So if you want to check on your calculator, there it is, 336. Just to be mildly irritating, and I would fix this for the exam, that number is going to be wrong. Sig figs. How many sig figs did we start with? We only started with 1, so officially that 336 would need to become 300, not 3. Okay. With no decimal point, grams of sodium hydrogen carbonate. Okay. That would for sure be fixed on the exam. How would I fix that? This would be 2.00 moles. Okay, make sense? Okay. So, we've gotten through a sizable amount of content here, and this should look kind of familiar to your old exam, or exam 2. But before we make that statement, what do you got?
And I say, and because the rest of it's just conversions, that's why we stick with the 3 sig figs, right? Instead of
Yeah, as opposed to going through here, because here I did lots of rounding. That was bad of me. Okay, I shouldn't be doing that. And your colleagues have actually already called me out on it for the practice exam. I did rounding when I shouldn't have. When it comes to those masses, what you should be using is the periodic table on your exam. Okay, because everybody has access to this. Not everybody has access to this. If you want to look at this to get a trend and see where things are, that's okay. It'll probably get you close enough to the right answer, but you should officially be using the periodic table on your exam to get those numbers and make sure that you've got more sig figs than you started with. Okay? So, this isn't exactly what was on your exam 2, but it was pretty close. Okay? So you were told for every mole of oxygen consumed, so we had 1 mole O2 equals 2.0. Don't write this down, by the way. It'll kind of become important. You might yell at me later, so if you really want to, you can. 1 mole of O2 is 2 moles H2O. We were told 9 grams of oxygen, told 16 grams of oxygen equals 1 mole of oxygen, which, by the way, you all should be good enough to be able to tell me that is false.
yeah. It's O or 32 grams.
Yeah, it should have been 32 grams of O2, so there's a big typo here. I think on your exam I fixed that, okay, but that was a pretty big typo, which made it fun to grade. And then you were also told 18 grams H2O equals 1 mole of H2O. So on your exam, all you had to do was set up your conversions. If you were comfortable with your conversion process, it runs through and it's fine. Okay? The problem with this, or what the next unit becomes, is where did that first conversion factor come from? What am I relating? What changed as far as units? The substance. Where's the substance information come from? Not quite. How do we convert substances? Begins with a B. A balanced chemical reaction, which means, because if you looked at your exam, right above that question, what did you have? Oh, the balanced chemical reaction for this, which means that information is given. 16 grams of O2 is 1 mole of O2. We know that's false because what did you do? You looked at the periodic table to say that it's actually 32 grams, which means you also knew that information. 18 grams of H2O equals 1 mole of H2O. Where do we find that? Also on the periodic table. So really, that question becomes this. 9 grams of oxygen gas are reacted with excess hydrogen gas, then how many grams of water are produced? Convert. Okay. This question becomes more difficult, and if you look at how we solved the previous question, where we had all the information versus how we solved this version of it, where we bring in those conversion factors will be entirely different, because the reason for why we're bringing in conversion factors changes. Right? So when we start this out, we've got our goal, and we have what we start with. Are those the same thing? No. Okay? So what's different about them? The substance is different. Right? So one of the first things that we could do, at least according to our old process, would be say I want to get rid of grams of water and I want grams of H2O to show up. Does that conversion factor exist? No. Okay? So that puts me in a boat of, well, now what do I decide to do? Okay? The argument that one might go through and make would be like, well, the only thing that changes here is the substance. Well, how do I change substances? If you know the answer, please be quiet. How do I change substances? If you don't know the answer, feel free to volunteer. How do I change substances? But I don't know the answer. I know. I want you to think harder.
I'm not sure, but I use moles.
Okay? Moles as a substance or as a measurement is fine. But that doesn't convert substances, because I can write moles and I can write moles. Does that do anything to the substance? No. Okay? So I'm okay with that measurement unit, and that's going to become very, very, very important. But that doesn't give me the context of how I change the substance. How do I make oxygen gas become H2O? Shoot, I don't really know. Well, let's read the question. And because all I'm concerned about is the substance, what am I going to choose to ignore? Anything with numbers. If oxygen gas, that's going to kind of bother me, sorry, is reacted with excess hydrogen gas, then how much water is produced? Oh, jeez. Well, oxygen gas. What is oxygen gas? O2 is reacted. What does is reacted mean? A plus. Excess, I don't care, hydrogen gas, okay, is produced, reaction arrow, water. So I'm taking oxygen gas, I react it with something, and I make water. Well, oxygen, I'm changing the substance. Oxygen gas no longer exists when this happens. It becomes water. I've converted the substance. I converted the substance using a chemical reaction. Is it balanced? No. What do I have to do? I have to balance it. In the process of balancing it, we'll notice we have to put in those 2's. Okay? What unit, what measurement unit is in a balanced chemical reaction? Okay? So we heard a suggestion of grams. Okay? If I give you 50 grams of bicycle tires and 500 pounds of frames, how many bikes can you make? Why? What's with the open arms?
I don't know how many pieces that makes.
Okay? When we build a bicycle, it's the number of pieces, not the mass of those particles. When we look at the chemical equation, this tells me the number of pieces, not grams. What is my unit for pieces? Moles. This is why your mole suggestion was really, really important. When we look at the chemical equation, I can convert using moles. Okay? When I go through and use that conversion factor, what mole unit do I want on top? What substance do I want at the end of my reaction? H2O. So moles of H2O should show up on top. What should show up on the bottom? Moles of oxygen. Why oxygen? So that the substance could potentially cancel. This conversion factor is really, really important and useful. But the problem with this, inserting this one here, is what happens to the units. They don't cancel. It's not wrong to bring it there. You've acknowledged that information is important and it does need to get used. When it gets used, now it becomes confusing. Okay? But we could pull this information in, 2H2O, 1O2. No units canceled out. So I made this more challenging for me. Okay, so let's try and get some units out of there. What units do I want to get rid of? Moles of, sorry, which one did you want to get rid of? Seriously? Fine. Moles of H2O. What do we want? We want grams of H2O. Okay? This would work. This gets rid of our moles of H2O. The seriously is because there was another way that you could have canceled 2 units as opposed to 1. It's not a big deal. Okay? So this gets rid of the moles of H2O. Where do I find the relationship between mass and moles? Periodic table. Okay, so what do I have to do? Hydrogen weighs, oh my gosh, 1.01 times 2 plus, that's a plus. Oxygen weighs 16. If you got a pack, you can pack 18 grams. For those of you saying, I could do that math in my sleep. That's okay, you should still show your work. Why should you show your work? So you can get your full points. Okay? I know that's simple. I'll try and pick something that's not so simple so you can't do it in your head. No? Okay, show your work. Okay? Moles of H2O cancel. Okay, so we now have grams of H2O, but what is the problem? We still have grams of oxygen, which needs to cancel, and I have moles of oxygen, which needs to cancel. Where do I find the relationship between grams and moles? Periodic table, so I just write 18 grams and 1 mole. No, because the substance is now O2. How do I get that number? 16 times 2, 32. Now if we go through and check our units, moles of O2 cancel, grams of O2 cancel, and we'd be left with grams of H2O. We now have the answer. All of that needs to show up to get full credit.
So it doesn't
Okay?
matter the order that
The
it is.
order does not matter. It's whichever you see that moves you through it. And that's fine. Okay? And yeah, sorry.